Okay. Let's see if you and your pod can come up with what goes in the blank. Can you and your pod come up with what goes in the blank? You may want to talk to each other. Just throwing that out there. Okay, which pod thinks that they know what goes in the blank? Pod 7, do you know what goes in the blank?
A to the y equals x?
She posed that as a question. A to the y equals x. She's looking for your reassurance. Yes. If we have a logarithm, remember base A raised to the y power equals x. Have you seen that pattern before? Okay. A logarithm is an exponent. Okay. There are times where we do not have a way to solve for an exponent. 2 to what power is 5? Okay. I don't know. The only way we can figure things like that out is if we write logarithms. Okay, so a logarithm is an exponent. You see that the logarithm equals y, that is our exponent. Okay, we need to be able to go from this form to this form to this form to this form. You have to go both ways. Okay, so let's first practice evaluating some logarithms. Okay, well, first we're just going to practice rewriting. Okay. Log base 2 of 16 equals 4. Why? Because 2 to the fourth power equals 16. Okay. Your base is always your base. So log base 2 of 16 equals 4. Base 2 to the fourth power equals 16. Log base 10 of 10 equals 1. Why is that true? Because 10 to the first power equals 10. Okay. There's a reason we're going through a couple of these, so I know these seem very obvious, but we're going to talk about these here in a little bit. Okay? Log base 3 of 1 equals 0 because base 3 raised to the 0 equals 1. Okay, let's talk about rewriting the other way. 2 to the fourth is 16. Oh, that was bad. Oh well. Our base is 2. So we have log base 2 of 16 equals 4. Raise your hand if you've seen this like circle notation, like with the arrows. 5 to the 0 is 1. Anything to the 0 is 1. That will become important here soon. If we write 5 to the 0 equals 1, we can also write log base 5 of 1 equals 0. Okay. Now I want you to just kind of take a look at what we did. There were some special logarithmic values that we worked with here in this list. So just take a look at it. Reference it if you need to. But we are going to fill out these logarithmic properties. Okay. Our first logarithmic property is log base A of 1. Log base A of 1. Take 10 seconds and see if you and your pod knows what log base A of 1 is going to be. Pod 1, what'd you say? I heard you talking.
It'd be 0.
It would be 0, and why is it 0? Why is it 0?
Because when you take a number to the power of 0, it's 1.
Good, because when you take base A to that power of 0, it will always be 1. So log base A of 1 is 0. If you see 1 inside of your logarithm, you automatically know it's 0. Okay, next order of business, log base A of A. Log base A of A. You and your pod have 20 seconds to determine what log base A of A equals. Pod 2. 1. Why?
Because anything raised to a 1 is already.
Okay, if we take base A and raise it to 1, we get A. So log base A of A is 1. If your base matches what's inside, the logarithm equals 1. Okay. This one is not quite as obvious. But see if you and your pod can come up with an idea for what this is going to equal. That means you need to talk. Pod 3.
It would equal x, because like if you have log base 2 of 8, that would equal 3, and 8 is 2 to the 3rd.
Okay, good. Let's write it in context of this. I like where you're thinking. If we take a to the x power, it should equal a to the x. Okay? What Jackson said, whoops. Okay. Jackson mentioned log base 2 of 8 is 3 because 2 cubed is 8. Well, we can rewrite this as log base 2 of 2 cubed. That was his example. Okay. These properties can help you evaluate logarithms quicker without a calculator. Okay. All right, and our last property, this is what we call the one-to-one property. I'll go ahead and fill this in for you. If log base A of x equals log base A of y, which would be true? X equals equals y. Okay, so we're going to do some evaluating here, and then after lunch we will work with graphing. Okay? Actually, you and your pod, I'm going to give you a couple minutes to see if you can evaluate these. Do not grab your calculator. I repeat, do not grab your calculator. I want you to evaluate these by hand. See if you can work together to come up with these answers. Okay, this is your 30-second warning. If you're stuck on anything, it's okay. We're going to talk about it. We're going to talk about it with each other. Okay, when you're evaluating log base 4 of 16, you need to ask yourself, 4 to what power is 16? Connor, what's the answer? What? 2. 4 squared is 16, so log base 4 of 16 is 2. Okay? When we are evaluating log base 5 of 1, 5 to what power is 1? Okay. This third one, this is where it gets a little tricky. 4 to what power is 2? Okay, remember, fractional powers mean we have roots. 4 to the 1/2 is 2 because the square root of 4 is 2. Okay? Log base 3 of -1. Will, what did you get for an answer?
I don't have an answer. I have no idea.
You have no idea. What's the issue?
I don't know what the exponent would be to get -1 from 3.
Okay. Is it possible to take a positive base, raise it to a power, and get a negative number? It is not. So, Will, don't panic. There is not an answer to this problem. It is not possible. You would say it's undefined. Okay? We can only plug numbers above 0 into our logarithm. Only positive numbers can be plugged in to our logarithm. Okay? Negative numbers, not okay. We can't take a positive number to an exponent and get a negative number. Okay? Before we go to lunch, let's just recall the natural logarithm. Okay? If you have log base e of x, you're not going to write it as log base e. You're going to write it as ln x. That means natural logarithm. Okay. To practice rewriting with natural logarithms, keep in mind that this is log base E of 10. So if we were going to rewrite this, our base is E. So remember, we take the base, raise it to the exponent, and that should equal what's inside 10. Same goes for the other way. If we have E squared equals approximately 7.3890. If we wanted to write this as a logarithm, we would write log base E of 7.3890 would be equal to 2. When we get back from lunch, we will talk about graphing. Enjoy your food.
Yeah.
All right, within your pods, I want you to have a quick discussion about the relationship of y equals 2 to the x and y equals log base 2 of x. What's the relationship?
Because it's 2 to the x is the other and then they go down the base.
All right, pod 4. What relationship?
Are they inverses?
Dave asked, are they inverses? Are they inverses? Okay, well, let's talk about how we find an inverse. If this is our function, how do we find an inverse? Okay, and then we rewrite log base 2 of x equals y. Dave, you are correct. They are inverses of each other. Here I have graphed y equals 2 to the x. Okay? We have the points -1, 1/2, 0, 1, and 1, 2, with a horizontal asymptote at y equals 0. If y equals log base 2 of x is the inverse, what do we do with this table right here? We switch x and y. Remember how we worked for a while on inverses? Inverses mean we switch x and y. So for our inverse function, we have the coordinate 1/2 -1. And we have the coordinate 1, 0 and the coordinate 2, 1. Okay. We no longer have a horizontal asymptote. We now have a vertical asymptote. Okay. This is the parent function for a logarithmic graph. Here the base is 2. If the base was something else, then these numbers would be slightly different. Okay? When we worked with exponential functions, I wanted you to plug in -1, 0, and 1 to your x column. Correct? Okay. When we talk about logarithms, I want -1, 0, and 1 still, but what column are they going to go in? They're gonna go in the y column. Those x, y values are going to switch. Okay? So this is the table of values that I want you to use for your parent function and then transform it if need be. Okay? So let's graph another parent function first. Questions on what I drew up here in green? Okay. Want to pick that up? Anybody? Huh? Well, I know, but I don't want it on the floor. Okay. So, this is a parent function where the base is 3. We still have a vertical asymptote at x equals 0. Make sure you draw that in and label it. If we're graphing a logarithmic function, where do I want the negative 1, 0, 1? In the y column. Okay. Since they're in the y column, you're plugging them in for the y's. Okay? So, negative 1 equals log base 3 of x. What's our x value if we plug negative 1 in for y? I'll hear them on both. 1/3, because base 3 to the negative 1 equals x. This is 1/3. Oh, that's not what I wanted. Okay. What about if we plug in 0 for y? Yes.
Before, but in case that would be undefined if you had a negative number.
If we had it inside the logarithm, right now we're plugging things in for y. Right? So we can think of this as 3 to the negative first equals our x value. The x cannot be negative. Okay? Okay. If we plug in 0 for y, what is our x value? 1. And if we plug in 1 for y, what is our x value? 3. You see how we have the same coordinates as 3 to the x, except x and y are just flipped. Okay? So 1/3 negative 1 and 3, 1. So there are my 3 coordinates, and we'll draw in our graph. Okay. For the parent function, you will have an x-intercept of 1 because of that property log of any base. If there's a 1 inside, it's going to be 0. So here we're going to have that x-intercept now at 1 for the parent function. Okay. What is the domain of this graph? Yes. 0 to infinity. Okay. First of all, we can only plug in positive values to our logarithm. Okay. Second of all, we have an asymptote at x equals 0, and we only have coordinates to the right of our asymptote. So 0 to infinity is our domain. What about our range? What is our range? Andrew, what would our range be? All real numbers. Okay. Notice how these are switched from yesterday's, right? If we have two functions that are inverses, their domains and ranges switch. Okay, so if 3 to the x had a domain of all real numbers, log base 3 of x has a range of all real numbers. Let's talk about if we have any transformations. Okay, here we have log base 3 of x plus 1 plus 2. Okay, so the first thing I need you to determine is the parent function. Since we have the base of 3, our parent function is log base 3 of x. Okay, let's talk about that parent function. When you determine what the parent function is, for a logarithmic graph, you're going to put the negative 1, 0, 1 in the y column, and then determine what your x values are. 1/3, 1, 3. Okay, so you figure out your values for the parent function. Then we need to do our transformations. Okay, so Jen, what are these transformations? Left 1 and up 2. Do you agree? Yes? Okay, so we need to take these coordinates and we need to shift them left 1 and up 2 so that we can get our new function. Okay. If we take 1/3 and we shift it, let's see, 1/3 negative 1. If we shift it left 1 and up 2, what's our new coordinate? Negative 2/3, 1. So if we shift it left, that means we subtract 1 from the x value. If we shift up 2, that means we added 2 to the y value. Okay? 1, 0, shifted left 1 and up 2 is now and 3, 1, shifted left 1 and up 2 is now 2, 3. Okay, I don't care if you plot it and then move it, or if you think about what the translations would be in your head, but I need these coordinates right here. Okay. Now, for our parent function, our vertical asymptote is at x equals 0. Is that still the case? Okay, where does it get shifted to then? Negative 1. Okay, it's usually at x equals 0. We have a shift left 1, so our vertical asymptote also gets shifted left 1. I need to at least see this in blue. Oh, I need to see these coordinates in blue along with your asymptote and your graph. Okay, let's talk about the domain of this guy. Hey Marissa, what's the domain of this graph? Where do we have x values? Good. Negative 1 to infinity. From the above the asymptote, we have values, right? Okay. Good. Our range, everybody. All real numbers. Okay. Our logarithmic graphs won't always have a y-intercept. This one has a y-intercept because it had a shift, but not all of them will. However, our logarithmic functions will always have an x-intercept. Okay? How do we find x-intercepts? Plug in 0 for y. So I can see that we have an x-intercept right there. How are we going to find it? We're going to have to plug 0 in for y. So let's go ahead and do that. 0, so this is our x-intercept. 0 equals log base 3 of x plus 1 plus 2. If we want to find the coordinate of our x-intercept, we plug 0 in for y, and now we need to solve this equation. How do we solve something that looks like that?
You subtract -2 on both sides. And then you switch it from logarithm to exponential.
Okay, good. We can move that 2 over, and now we have a logarithm that we can rewrite as base 3 to the -2 power equals x plus 1. 3 to the -2nd really means what? Okay, 1/9. Very good. So when we subtract 1, our x value is -8/9. Okay, so we subtracted the 2, we rewrote it into exponential form, and simplified from there. So our x-intercept is at -8/9, 0. The x-intercept for logarithmic graphs is something that you'll find in your homework tonight, as well as on Thursday's review and on Friday's quiz. Okay, so I just want you to be aware of that. Very quickly, I want to talk about the natural log graph. Okay, remember this is just log base e. So we will still have x equals 0 as our asymptote. Our xy table for logarithmic graphs, where does -1, 0, 1 go? In the y column. Your energy has really died down after lunch. Let's get it back. Okay? What goes on the left side? What goes in our x column? 1 over e, 1, and e. Right? We have e to the x, but now we've switched x and y. Okay? When you graph these, I don't want you to graph them in your calculator, but you will need to use your calculator to approximate those values. Okay? So you will have some in your homework this evening where you have to graph natural logarithmic graphs. I don't want you to use your calculator to graph them, but you are going to have to use your calculator to help you approximate some of these values, and that's fine. Just remember, on Friday's quiz, these graphing problems will be on the non-calculator portion of your quiz. Okay. In your pod, I'd like you to talk about the transformations for this graph. Okay, pod 7, what are the transformations?
It's reflected in the y-axis and it's straight to.
How do you feel about pod 7's description? A reflection in the y-axis and then right 2. Yeah? When the negative's on the outside, it affects the y value, so we reflect about the x-axis. If the negative's on the inside, it affects the x values. That's when we reflect about the y-axis. Okay? Good things to keep straightened out. Okay? This is actually a reflection about the x-axis. Okay? So from our points, from the coordinates that we had on the previous slide, right, we had these. Okay, we would move them, we would reflect them about the x-axis and then move them right to. So this would go up, right. Since we have a reflection, or excuse me, since we have a shift to the right too, our vertical asymptote also gets shifted right too. Okay. I'll tell you, I really want you to focus on the logarithmic graphs that have whole number bases. Okay, that's what you're going to have to graph on Friday's quiz and next Thursday's test. So you're, oh, I have another slide. Oh, yes. This is a good example. I forgot I had this example. Okay, we talked about this property. Talked about this property way, feels like forever ago, at the beginning of class. Okay. We have two logarithms that are equal. Are their bases equal? If two logarithms with the same base are equal, what is true about what is inside? What was I going to do? They should be equal. So since log base 5 of 2x plus 3 equals log base 5 of x plus 1, then 2x plus 3 should equal x plus 1. Which means x equals -2. Is -2 an appropriate answer?
No.
Did I even do that right?
Yeah, you did.
Okay. Is -2 an appropriate answer? If I plug -2 in to this right here, what's wrong with that? We have a negative inside of our logarithm. Since we can't plug it back in, we don't have a solution. So when you're solving these logarithmic equations, it's important that you make sure your answer is legitimate. It might work algebraically, but it does not work back into the logarithm. Okay. Your homework is on your gold sheet, which is the same as what's written up here. Make sure you're keeping up with your homework. Yes, they're in that yellow folder back there.